Oh, I'm sorry, what's that? Are those scream of joy I heard? Because redox is back. We're going to talk about oxidation reactions of organic compound, and I'm going to try not to sound too cheerful by the fact that redox is back, but I am generally very happy because I really like this topic. But here goes. So let's just quickly recap. We're going to focus specifically on oxidation, and beside the official definition, which is the losing of electrons, you can also recognize oxidation as a reaction that involves gaining oxygen or losing hydrogen atoms. And especially in the context of organic chemistry, this is probably easier for you to recognize because it takes a while to find oxidation numbers when you have an organic compound. Now, oxidation can only occur, that's I can't spell, in the presence of an oxidizing agent, and obviously the oxidizing agent would undergo reduction or it will gain electrons. There are two common oxidizing agents that are used to oxidize an organic compound, and you do need to know them. They are potassium permanganate, or KMnO4, or potassium dichromate, K2Cr2O7. Now, really, it is just the ion here that undergoes reduction. So MnO4 minus or Cr2O7 2 minus. The potassium ion is just a spectator ion. You also normally require the addition of protons. So normally we're going to have acidified conditions so that you have enough hydrogen atoms to balance the half equations. Okay, so there are two, well, really only one type of oxidation of organic compound that you need to know for BC chemistry, and that is the oxidation of alcohols. Now, before we start, I need to, and I don't think I've talked about this in my class, I need to make a distinction between primary, secondary, and tertiary alcohols. Obviously, the third one is going to do a degree in something useless and accumulate a lot of hex debt. But anyway, so primary alcohol are alcohols in which the OH group is bonded to a carbon that is attached to only one alkyl group. That makes no sense. So basically, this is a primary alcohol. So another way to understand primary alcohol, which probably makes it easier, is that the hydroxyl group is on a terminal carbon. So OH is here. This is on terminal carbon. So this carbon is only linked to one other carbon in this primary alcohol. Now, secondary alcohol is when the hydroxyl is linked to a carbon that is linked to two other carbon. So that's secondary alcohol. So you can see here that this carbon is linked to 1 and 2 other carbon. So that's your secondary alcohol. So obviously tertiary alcohol, the carbon, the carbon that is the hydroxyl group is linked to a carbon that itself is linked to 3 other carbon. So that's a tertiary alcohol. So primary is 1, secondary is 2, tertiary is 3. You can't really have a quaternary alcohol because one of the link has to be on the hydroxyl already. So this is the maximum number of carbon that this C can form. So 1, 2, 3, tertiary alcohol. Primary alcohol, secondary, and tertiary. Now, the catch here is that different types of alcohol is going to have different oxidation reactions. Not too different, but anyway. So let's start with the oxidation of primary alcohols. So primary alcohols can be oxidized into an aldehyde, which then get oxidized further into a carboxylic acid. So this is what it can look like, and I got this from the textbook. So let's say we have propane 1O, which is a primary alcohol. Now, essentially what happens, and you can see, normally this is what they would write in the pathways which to indicate that an oxidation has taken place, because Cr2O7 is your oxidizing agent, and H plus is a condition. So you can use cohes to balance the equation. Oxidizing, oh, you think you are done with cohes? No. Okay, so this is the oxidizing agent. So what happens here is that this carbon has lost 2 hydrogen, one here and one here. So you can think of it that way. 2 hydrogen has been lost. Remember, one of the earlier definitions of oxidation is the loss of hydrogen or the gaining of oxygen. So in this case, it has lost 2 hydrogen atoms. So to go from an alcohol to an aldehyde, because it has lost two hydrogen, in order to fulfill the octet rule, it needs to form a double bond with the O, so you have an aldehyde here. Now this aldehyde still has a hydrogen remaining that can be lost, so it can undergo another oxidation. So you can use the same oxidizing agent and conditions. Basically, if you leave this reaction for very long, then the alcohol can go straight to carboxylic acid and the aldehyde is just an intermediate. But this hydrogen is now going to be lost, and also in the process you're gaining an oxygen. So you turn it into a carboxylic acid. So primary alcohol can be oxidized to an aldehyde, which can continue to be oxidized to a carboxylic acid. If you want to make a carboxylic acid from a primary alcohol, you can. Aldehyde is just going to be the intermediate. All right, let's write the half equations and the full equations for this process. I'm just going to go primary alcohol to aldehyde first. So if when you write half equations and full equations, it's a lot easier to use molecular formula rather than structural formula. So let's just start with propan 1L to propanal. So propan 1L to propanal. I may not have enough space here. So if we look at the reactants, it's C3H8O, and this goes into C3H6O. So you can really see that two hydrogen atoms have been lost. Now, because if you look back, sorry, I keep going back to the previous slide. This is acidified condition. So this is an acidic condition, which means that you can use cohes for balancing. It is entirely possible for this to be converted to a basic condition. In that case, you have to convert your half equations into a basic condition half equations. Okay, it's not actually that bad. C3H8O going to C3H6O. You could do your what am I saying? Identification of oxidation numbers, but I can tell you right now that carbon is going to be the atom undergoing oxidation. So key element is going to be carbon. It's already balanced. I need to balance oxygen by adding water. Oxygen is already balanced. So I really only need to add 2H plus and 2 electrons. So this is going to be the oxidation. I'm going to say this is a liquid. Now, the key thing here is that this reaction cannot happen by itself. It does need to have a reduction counterpart, just like any other redox reaction. So because the oxidizing agent that I use is dichromate ions, I would have to write the reduction of dichromate ion. You do have to memorize this, by the way. The fact that dichromate ion, when undergoing reduction, it's going to produce Cr3+. I don't think you need to memorize the entire half equation. If you know how to use cohes, you can write it every time yourself. But keep in mind that Cr2O7 2- will undergo reduction to form Cr3+. And if we follow cohes, balance key element at 7H2O, at 14H+, and at 6 electrons, and that's going to be your reduction. Now, if I had to write the overall equation, before I can add these two together, I have to triple my oxidation so that the number of electrons match. So the overall is going to be 3C3H8O2, sorry, O, plus Cr2O7, 2 minus, plus 14H plus. Actually, we can cancel a few things out. Let's just write the C3H6, the reactants and products first. That's a 3. 2 Cr3 plus. Okay, so that's 6, 14, so 8, and 7H2O. I'm just going to do a quick check to see that my equation is balanced. I did go through this fairly quickly. Again, it is revision. So let's check the oxygen. I have 7, 10 oxygen, and 10 here. I have 18. Oh my god, I can't really do math today. What is this? 32. Okay. And then that's 24. Yep, 32. We're good. So that's only propan-10 to propan-now. Another slide, because the propan-now can also undergo oxidation to form carboxylic acid. So let's just create another slide here and duplicate. It should not take this one. Okay. Sorry about that. So propan-now going to... Now sometimes people combine the two oxidations, so they just ask you to write propan-10 going straight to propanoic acid. But really there are two oxidations that has taken place. Propanoic acid. You can go back to the previous slide, but the molecular formula is just C3H6O going to, not that I remember, C3H6O2, I think that's right. Okay, is it this one? This one. Yep, C3H6O2. So again, you can clearly see that an oxidation has taken place, in this case in the form of gaining an oxygen. So the oxidation process is going to be propanal to propanoic acid. This one's a little bit harder than the previous one, but it's not impossible. We've done harder equations than this. So key elements carbon, which is balanced. I need one H2O here and two H plus. Well, this is pretty easy. And two electrons. Okay, AQ and liquid and liquid and liquid. So the reduction is going to be identical because you are still using dichromate ion as the oxidizing agent. So it's just going to be dichromate going to Cr3 plus again. Key element 7H2O, 14H plus, and 6 electrons. Okay, so once again, if I want the full overall equation, I need to triple my oxidation so that the number of electrons match. So I will have 3 C3H6O plus Cr2O7. Now this is a good opportunity to revise redox, which I think this is the reason why redox is such a big part of the exam, because it appears in both Unit 3 and Unit 4. So there is really no way that you can escape redox. The only way is to get better at it. But you know, you're gonna be fine. Just cohees. Cohees is the least of our problem. At least it's not electrolysis. Okay, let's be diligent and actually check. But I think it looks fine. Okay, so that's it. Oxidation of primary alcohol. You can turn it into an aldehyde, which then turn into a carboxylic acid. Now, if you compare primary alcohol with a secondary alcohol, the main difference is that the secondary alcohol doesn't have, so this is a secondary alcohol. Okay, so secondary alcohol can undergo oxidation as well. So these two hydrogen will be lost to form a ketone. And obviously, because originally the carbon that is linked to the hydroxyl group is linked to two different carbons already, when oxidation occurs, you just have a C double bond O in the between the chain, which is why it produces a ketone instead of an aldehyde. But because this C double bond O doesn't have any extra hydrogen to lose, it cannot undergo any further oxidation to form a carboxylic acid. So only the aldehyde, which has the functional group in the terminal carbon, can be oxidized further to form a carboxylic acid. Ketone, which has the functional group in the middle of the chain, would not be able to do so. So secondary alcohol would just stop with a ketone. Now the thing is, you won't be able to tell by looking at the molecular formula that something is an aldehyde or ketone, because aldehyde and ketones are actually structural isomers of each other, and the same can go for primary versus secondary alcohol. So if I just go C3H6O to C3H6, actually sorry, the original one was C3H8O to C3H6O. If I just give you the molecular formula, you wouldn't be able to tell whether or not it is a primary alcohol or secondary alcohol. So in order to illustrate this, you do need the structural formula, but if the question just asks you to write the half equations, molecular formula is fine. What I'm trying to say here is that if you start with molecular formula it's impossible to tell whether the reaction can continue or whether or not this is an aldehyde or ketone. So there has to be other pieces of information in the question to allow you to do so. But the equation is going to be identical to the previous one that we just write. So I'm just going to add 2H plus and 2 electrons to this one. I'm not going to write it all full because it looks the same. And then, but how, actually no, I'm going to write it. Let's say we're going to use the other oxidizing agent, which is potassium permanganate or permanganate ion. This is another one that you have to remember. Permanganate ion is going to be reduced to Mn2 plus. And then you should be able to use cohes to balance the rest. 4H2O, 8H plus, and 5 electrons. Okay, and now this is actually a little bit more interesting to write the full actually. I should write the full here because you have to multiply the oxidation by 5 and the reduction by 2. But that shouldn't be difficult. So 5C3H8O liquid going to 5C3H6O. Okay, and then 2Mn04 going to 2Mn2 plus. All right, so what is this? I have 10 here, 16, so I need 6H plus and 8H2O. Let's see whether my hydrogen is balanced. That's 16 and that's 30. So that's 46 hydrogen overall on the product side. I have 6 here and 40 here, so 46 hydrogen overall. So that's hydrogen's balance. I'm going to check the oxygen as well. So I have 8 and 5, so 13, and then 5 and 8. So that's the full equation. Now, tertiary alcohol, if you draw the structure out, so COH, there's a C here, there's a C here, and a C here. So the problem with tertiary alcohol is that it doesn't have enough hydrogen. In order for the original oxidation to take place, the alcohol has to lose 2 hydrogen, one from this H and one from the carbon. But tertiary alcohol doesn't have enough hydrogen, so it's actually not able, it's not going to be able to undergo an oxidation reaction. So no oxidation. Okay. And that's it. Let's just, actually no, I have to talk about this as well. Another color change that you can use, so you can't actually distinguish between primary and secondary in this case because they both can undergo oxidation. But dichromate ion is yellow and the chromium ion's product is green. So if you see a change of color going from yellow to green, that is an indication that the alcohol that you have is either primary or secondary. Tertiary alcohol is not going to be able to achieve this change of color. So that's one way to detect whether your alcohol is tertiary or not. Unfortunately, you can't dissociate between primary and secondary this way. You would have to do some extra detection to distinguish between the two. Similarly with permanganate ion, permanganate is dark purple and manganese ion product is colorless. So if you see a color change going from dark purple to colorless, you either have a primary or secondary alcohols on your hand, but tertiary alcohol is not going to be able to do that. So in summary, when you have alcohol, there are 3 types. The primary, now this is my abbreviation for primary. The primary can undergo oxidation, so you need H plus, MnO4 minus, or H plus Cr2O7, 2 minus, and this is going to give you an aldehyde. If the process continues, let's just write it on top here. Now, most of the time, if you want to go from alcohol to carboxylic acid, you just need to wait a bit longer, or you can increase the temperature of the mixture. So you speed up the reactions. You can have like high temperature, and the 1,2-aldehyde doesn't require that. Then eventually it's going to turn into a carboxylic acid. So that's primary alcohol. I'll write the word primary out. This may confuse some of you. Secondary alcohol, on the other hand, can only undergo one oxidation to ketone. So H plus, MnO4, minus, or I don't know why the arrow is longer. I don't have any reason for that. H plus Cr2O7 to minus. So that's going to give you a ketone. And that's it. It cannot go to carboxylic acid. So if you want to make a carboxylic acid, you have to start with a primary alcohol. Tertiary alcohol can't do anything. Tertiary, no oxidation. And that is the end of organic pathway. Now we're going to combine all of them and then make interesting products. We'll talk about that next time.